In this video, we are going to introduce a couple different short-term forecast techniques. Particularly, the two examples that we are going to discuss is the moving average and the exponential smoothing. Traditionally, we can do the forecast by calculating the average, but the traditional way to calculate the average can only give you one single number based on all historical data, and practically there might be too much data to collect. Secondly, it fails to catch future trend, which is more likely to be revealed from the most recent observations. So we need to find a way that can take more weight on the most recent data so we can catch the future trend. That would be the main purpose for doing the forecast. So the first methodology that we are going to talk about is the moving average forecast, and we call it MAFT. T is the parameter to tell us that how many data points that we want to consider. For example, if we say we want to calculate the moving average forecast for MAF4, it means that we only want to consider the most recent 4 observations. For example, if we want to calculate the forecast for period number 5, and we want to do the calculation based on the most recent 4 observations, then the calculation will be based on these 4 numbers, and the forecast result for period number 5 will be 3 plus 6 plus 3 plus 4 divided by 4. That's how we get the number 4 here. And when we move to period number 6, let's say we want to do the prediction for period number 6. Again, we only want to consider the 4 most recent observations. That will be from period number 2 to period number 5. So the calculation will be 6 plus 3 plus 4 plus 7 divided by 4. And you can do the same thing for calculating the forecast result for period number 7 and period number 8. Just remember, we only want to consider the most 4 recent observations. And this is another example. If we want to do a prediction for period number 7, it will be 3 plus 4 plus 7 plus 6 divided by 4. Okay? So how can we decide what will be the right observation size? If we choose the n that is too large, then most noises can be filtered out, and it is much more similar to the traditional average calculations. However, your forecast result will be very flat, and it will be very hard for you to catch the future trend. And also, it requires you to store more historical data because you need to have a larger sample size for you to calculate the average. On the other hand, if we choose an n that is smaller, the result can be affected by noises easier. However, the forecast also have a higher reliability, which means that more likely you will be able to catch the future trend. So these figures show you the different forecast results based on different observation size. The black line will be our real data point, and the yellow line means that we want to consider the most recent 20 observations, and the orange line means that we only want to consider the most recent 3 observations. As you can see on the orange line, it can catch the trend much easier. When we have a spike over here, we kind of catch that right away. And you can also see a larger variability. The result will be going up and down more frequently because when we have a smaller observations, it is more prone to noises on the original data set. But if we focus on the yellow line, you will notice that it is pretty smooth, pretty flat. It can still catch the trend. As we can see, we have an increasing trend here, then kind of a decreasing trend right here. But as you can see, if you focus on the black line, the decreasing trend actually will start right from here. But we did not catch that until probably couple periods after. So it will be slow react, the reaction will be much slower considered to the one that has a smaller observation requirement. The second methodology is what we call the exponential smoothing. And the reason that we want to use the exponential smoothing is that we want to find a methodology that is more sensitive to recent observations. When we use the moving average, although we only consider the most recent historical data, but every single data point will have an equal weight. But when we try to use exponential smoothing, the recent data will have a higher weight, but the older data will have less weight, and that's how it works. So the first thing you want to do is to choose the parameters called exponential smoothing constant alpha, and your prediction in the end of period t will be alpha times your actual demand for period t plus 1 minus alpha times your exponential smoothing from the previous period. Okay? For example, if I want to do the prediction for period number 5 and assume my alpha is 0.3, my calculations will be 0.3 times my previous observations, which is 4, plus 0.7 times my previous exponential smoothing result. And if I want to do the prediction for period number 6, then it will be 0.3 times my previous real data plus 0.7 times my previous predictions. And you keep doing this until you got all the forecast results you want. So why is ESF is better? It works as a weighted moving average with a higher weight on most recent observation without ignoring the older observations. And if you work out the mathematical formulations in detail, you will see that my exponential smoothing for period t will be equal to something like this. And as you can see, the weight for the most recent data will be alpha. For the older data, it will be 1 minus alpha of power n times alpha. So we got a higher weight at the front and lower weight in the end. And this will be a simple comparison. The first row will be the moving average with 5 recent periods. As you can see, we put a 20% weight on the most 5 recent observations. So if we want to do the prediction for period number 9, it will be 20% based on the result on period number 4, 20% on period number 5, same thing for period number 6, 7, and 8. However, if we want to use the exponential smoothing with parameter equal to 0.3, 30% of the weight will be put on the most recent information, and 2% of the weight will be put on period number 1. So we consider all the data points, but we put more weight on the most recent information. Again, how can we choose the right alpha? When the alpha is high, the result can be affected by noise, and the forecast will have a higher availability, but you will be able to catch the future trend more easily, because when the alpha is higher, you put more weight on the most recent data. But if the alpha is much smaller, the noises can be filtered out, but the forecast will be pretty flat and the reaction will also be slower. And this is the same pro and con as compared to the moving average. So let's see different comparisons. When we set the alpha equal to 0.9, because we put a large weight on the most recent data, as you can see, it is almost overlapping with the historical data. However, if we put the alpha as 0.1, the result can be very smooth, but the reaction is also kind of slow. So you need to find a balance between the two. So how can we evaluate the forecast result? Couple of things that you can calculate. The first one is called a mean error, or we can call it bias. It can check if the forecast has some systematical errors. For example, whether our result is always higher than the actual result, or whether our result is always lower than the actual result. Okay, And we can also calculate something called mean absolute deviations, or we call it MAD. This is just to check the accuracy of the forecast result. And we can also convert the MAD to the standard deviations. And to do that, you just want to approximate the standard deviation by multiply 1.25 by your mean absolute deviations. So how can we calculate the mean error? The first thing you want to do is to find the difference between the actual data and the forecast result. For example, let's say we do the forecast for period number 1, 2, 3, and 4. And after period number 4, we also get the real observations. The first thing you want to do is to find the difference between these two. And 1500 subtract by 1600 is negative 100. And 1400 subtract by 1600 is negative 200. 1700 subtract by 1400 is 300. 1200 subtract by 1300 is negative 100. Once you get the error, you just need to sum up all these errors. So we got negative 100 minus 200 plus 300 minus 100 divided by 4, and we know the average error will be negative 25. The mean absolute deviation is slightly different because we want to take the absolute value for your error term right here. So instead of editing these four numbers together, we first want to convert those to the positive number. So we have 100 plus 200 plus 300 plus 100 divided by 4. I know my mean absolute deviations will be equal to 175. So let's try to solve the problem together to see if we know how to do it. Let's assume the alpha is equal to 0.5, and we want to complete the following table using exponential smoothing. So the first thing we want to do is to calculate the forecast result. Okay, and we know if alpha is equal to 0.5, it means that I want to use the actual data times 0.5 plus my forecast result from the previous term multiplied by 0.5, and this is equal to 101.25. Similarly, for the next term, I have 100 times 0.5 plus 101.25 multiplied by 0.5, and this is equal to 100.625. Then for the period number 6, I don't know why the slide is jiggling. Okay, it will be 130 times 0.5 plus 100.625 times 0.5. That will be, let's see, 115.3125. Then to calculate the error terms, we want to use the actual demand subtract by your forecast result. So here I have 100 subtract by 90, which is 10. This one is 120 subtract by 95, which is 25. The third one will be negative 12.5. 4 will be negative 1.25. Period 5, 29.375. Period 6, negative 35.3125. Okay, so for the mean error, it will be 10 plus 25 subtract by 12.5 subtract by 1.25 plus 29.375 subtract by 35.3125. Everything divided by 6, I got 2.55. For the mean absolute deviations, it will be 10 plus 25 plus 12.5 plus 1.25 plus 29.375 plus 35.3125 divided by 6. Again, the answer will be equal to 18.906. And the next thing we want to discuss is called pyramid forecasting. This is a procedure to ensure we got a consistency between the various source of forecast based on the company's constraint or goal. So in a company, we will do the forecast on a different level. For example, initially we have a forecast result for the entire company. Then maybe we will have the forecast result for one particular product line, and we will have a forecast result for a particular product. And the roll up means that once you get the updated individual products forecast, we want to use that information to update your forecast for your product line and the update result for your entire company. And the fourth down means that once you have the new forecast result for your entire company, we want to pass down that information to individual product. Okay? In this example, we have 3 layers of forecast. The first one is the business forecast. The second layer will be the product line forecast, and the bottom layer will be the product forecast. So for the business forecast, we have $950,000. That will be the profit or revenue, doesn't matter. And for the line forecast, for the X product, we assume that we will be able to sell 15,000 units, and for the Y series, we'll be able to sell 25,000 units. And for the X series, we'll have 2 different products. For X1, the forecast shows that we will be able to sell 8,200, and the unit price is $20.61. And for X2, it will be 4,845 units, and the unit price will be 10. So this is what we want to do. We want to use a product forecast to update the line forecast result. So the first thing we want to do is to sum up all the number of units that you want to sell. So we have 8,200 plus 8,845 units. So the total unit will be 13,045 units. Okay. Then we want to calculate what will be the average unit price. So we use 8,200 multiplied by the unit price, 20.61, plus 4,845 units times 10, divided by the total number of units, and the new unit price will be 16.67. So this is what you need to write down. For the X series, my updated number of units will be 13,045 units, and the unit price will be 16.67. And you can use that to do the calculation for Y. I'm not going to show you the detail, but you can assume that for Y series, the updated unit will be 28,050 units, and the unit price will be 20. Then, based on the line forecast result, we can update the business forecast. What you want to do here is to find out what will be the total revenue. So 13,045 units multiplied by the unit price. This is for X. The second part is for Y. So the total revenue will be $778,460. Okay. So you just write that down. Let's assume that we have the updated business forecast result. That will be 900,000. How can you use that information to calculate the updated line forecast and the product forecast? So here's what you want to do. First, you want to calculate what's the percentage of change from your old forecast to the new forecast. So originally, our result will be 778,460. The new one will be 900,000. So you just use 900,000 divided by the old forecast. It will be 116%. Then you can update the number of units by using 13.67 30,045 units multiplied by 160%. So this is how you get this number. Similarly, for the product Y, you can use 28,050 units multiplied by 160%. This will help you get the new number for product Y. And for the individual product level, you can do the same thing, because the number of sales will be increased by 16%. So 9512 is coming from 8200 multiplied by 116%, and 5602 is coming from 4845 times 160%. So this is what we call a force down.